This tutorial is about numerical data files. Now, more specifically, dlmread. And one of the examples is going to be about wing shapes, otherwise called airfoils. There are a lot of files online that we can find with the X and Y coordinates, so it's really a perfect example. Now remember that if you have to decide what level of function to use, high level or low level, there's only two high level that we'll introduce this semester. Either it's Excel, and then we'll go with XLSRead, or it's all numerical values and a unique delimiter. Then we'll go with dlmread. Now, as far as explaining unique delimiter, what delimits each column. Here in the example we have a dash. So the delimiter in this file is a dash. More commonly we'll probably have white space or colons or tabs, but this particular file has a dash delimiter. Now, as far as the organization overall, we have 6 columns and they're all neatly organized. There's no holes anywhere. So dlmread is a perfect candidate for this file. Now, couple examples. This one was perfect. If we just decide to add an extra column, all of a sudden we have 2 delimiters. One is the dash and one is the space. This is not unique anymore, so dlmread is out of the question. In this one, we have a comma. dlmread is also out of the question. This one is okay. The dot indicates floating numbers, so MATLAB can easily differentiate between decimals and integers. The delimiter here is white space. This is the default of MATLAB. As long as we have white space between numbers, MATLAB considers this to be a different column. So there are indeed 6 columns. They may be a little bit funky and misplaced, but this is okay. This one is okay too. The delimiter in this case is a colon. There are still 6 columns. MATLAB can easily use dlmread. Now, from the help file of MATLAB, dlmread is to read an ASCII delimited file, and it is very specific that all the data in the file must be numeric. dlmread does not operate on files containing, for example, letters, but as soon as you open a file and it has a letter, dlmread is out of the question, so it's really easy. There are a couple ways to actually call the function. Result equals dlmread file name. So the first argument is actually the name of the file. MATLAB will pull out the numbers and create an array automatically and store it in the left side of the equal sign. So result. If the delimiter is not the default white space, if it's a tab, if it's a colon, if it's a semicolon, if it's a dash, a question mark, any kind of character that is not common, that's out of the ordinary, then it's in the second argument and inside quotes. As far as the first example, airfoils and plotting. The NACA airfoils are airfoil shapes for aircraft wings developed by the National Advisory Committee for Aeronautics. So there is a link for Wikipedia, and it basically presents the different shapes, the different vocabulary word. It even gives the y coordinate function of x. So if we have all the x data points, we can calculate the y distance and design our own plane. We could do this on paper with a ruler and a calculator. There are, however, many databases online. You can easily Google NACA airfoil data files and find a lot of lists of aircraft wings of NACA files. For example, the University of Illinois has a huge database, and they're alphabetic. We can easily go and search the NACA airfoils, and right here. On the right side is the actual GIF file, so the plots have been done for us. We can look at them very easily. On the left side, however, is the .dat file, and when you download it, the file has the x coordinate on the left side and the y coordinates on the right side. Now the only downside to this one is that it has letters, but if we simply delete it, then we have all numerical data and dlmread can do the job. So I can save it in a directory where I'm going to work with my example. Once we upload into arrays in MATLAB, we're going to use slicing to extract the x and y coordinate, and then it will be easy to plot the airfoil. So I've developed the algorithm right here. First, upload the numerical data from the file. Second, get the xy coordinates. Third, plot, add a title, grid, and make the axis look good. Now the first thing that we have to do is to actually make sure that on the left side here you see your file. The file is on your laptop, but MATLAB is not going to look through your whole entire laptop to find it. So it's important that the folder where this file, this script file is next to the file NACA that we want to look at. So for this purpose, use the ... and browse to where your example is. As soon as you hit OK, MATLAB changes directory. So now I have this script file right here and my data file right next to it. So my array is going to be dlmread and the name of my file. Remember to put the quote since this is a string. Omit the semicolon and run just to see that it works. We can see all our x and y coordinate just like they were in the file. Again, this is a high-level file, high-level function. Very simple, only one line of code. The rest is a piece of cake. To extract the x's, it's all rows, first column, slicing. To extract the y, all rows, second column, slicing. And to plot x, comma y. Let's run. In 4 lines, we have plotted the NACA 2410 airfoil. Now it looks a little bit different because if you see the axes, they're not the same scale, which makes this airfoil really funky. Couple steps to change this is to make the axes equal. To turn on the grid, that will make a huge difference. So now a square is 0.1 in this direction and 0.1 in the same direction, same scale. That actually looks like an airfoil. The last thing finally is a title. To put a title is nothing but the actual title function with our string. We have a title, we have a foil, and we have the same scale on both axes. So that completes our example. Notice the line that reads the data file. Very simple. Now the reason why we didn't put a delimiter is because it was delimited by white space. You can always click right, open outside MATLAB, and look at the file from here. The delimiter here is definitely white space, which is the default for MATLAB. So that concludes this example. The second example is a little bit longer about analyzing sales. Here is the email from the client. Please find attached a file, sum up the last column for each month. Month are in column 2 and will be in the right order. So apparently we'll all have November's, December, January, February, March, April in the right order. This is a small test file. We'll email you the big one when we have it. Email us the results. Thanks. So we're basically supposed to give them a report on September, you sold that much. October, we should sum these two. And December, we should sum these two. Now when we do it on paper, it's pretty straightforward. But as far as solving it by hand, remember that it should help us develop the algorithm. So what we did is basically we started with the first line and we kept in track of the numbers on the far right. Then we looked at the next line, and if it was different, that was our total for that month. If it wasn't different, for example October, we would just keep a running total. Load data from file first and calculate sales each month. This is definitely not the final algorithm, but step by step. Now again, always check that your file is on the left side, and right now I'm still on the airfoil design. So make sure that using the ... you actually go get the other folder that has your correct file. So if I change and hit OK, now I have my Flagger sales text file. And again, I can check quickly that it didn't get messed up by email, by transfer, and the delimiter here is dashes. So if I proceed the same way as with my airfoil, dlmread, the name of the file, remember that it needs to be a string, and if I run it, I look at the result and I notice something very strange. I didn't get all my numbers. This is because we have a delimiter that's different than the white space. MATLAB understood it as -9 and negatives and negatives and negatives. So this is where the second argument is absolutely necessary. Tell MATLAB that the columns are delimited by dashes. Try it again, and all of a sudden we have the exact same thing that is in our file. Now in order to calculate the actual sales each month, well, first we need to know how many rows we had. When we did it by hand, we kind of looked and we knew that we were going to end on row number 5. Then we looped a specific amount of time from 1 to the number of rows that we had, which is why it's essential to figure out the number of rows. In this particular case, we will use size, comma 1. This finds the size of this array and the first dimension only. We really want to know how many rows there are. We don't care about the columns. So this will loop how many ever rows we have. That's for certain. After that, when we did it by hand, we started by adding the column number 6 and keeping a running total. That was the idea. And as soon as we added the first one, we had to go check first if there was a next line. We could have reached the end of the file already. If there was a next line, if it wasn't the same month, then we did something, which was print the result and reset the sum. If there was no next line, meaning we're at the end of the file, just print the final sum. So that's basically what we did on paper, and that's a skeleton algorithm, but always prepare your algorithm first. Running total, well, we're calculating the total sales and we're adding from your array that specific row, and we decided column 6. Now this is a running total. Always remember to initialize to 0. If there was a next line, if there was a next line, remember that right now we're on this particular line. So if there was a next line means that we have not reached the total number of rows. I can set up and I can finish that if statement. If it wasn't the same month, so if the next line is not the same month, well, the current month that we're on is in column number 2. The client told us that. And if the next row plus 1, column 2, is not equal to row column 2. So we're looking at this row and this row plus 1, so the next row. Then we'll print the result and reset the sum. Reset the sum means total sales equals 0. But before we reset it, make sure you do tell the user which month you were on and how much they sold for. The month that we're on is in row column 2. I'm going to run out of room, so I put the ... and nope, the sales that they did is total sales. Now if there was no next line, we just needed to print, so I easily can copy paste that statement. So let's run and test. Oop, I forgot the % sign. Percent, and since I copy pasted, I took the arrow with me. Now I don't necessarily need to see my array anymore, so I'm going to go up and put my semicolon back and run. So on September 153, on October 282, and on December 322. That is definitely what we had on paper. So this file is posted, but this is the important line today. This uploads the data file in one single line. Because it wasn't white space, remember that we have a delimiter, a very specific delimiter, as the second argument. But that concludes this example. So as far as vocabulary, delimiters. Basically it's what symbol does the human eye see that delimits every column. Recognize if dlmread will work with the specific input file is crucial. Because if you start out thinking it will work, but there's for some reason a character somewhere in the file, it will make your whole code wrong. And we saw two examples, one with white space delimiters in the airfoils, and one with the dash delimiters. So that concludes this dlmread explanation.